There are three different ways to solve a system of linear equations. The first we've already used was graphing. This is where you graph each line and look for where they cross. The second one is substitution. Substitution is not a new concept. The idea is you replace one thing with another. So I have two equations. If I can take this down to one, I can then solve. In both cases, I see that y is equal to, and then we have a mess of information, negative 2x plus 2, or y equals 3x minus 8. No matter what, y is going to be the same though. Y is equal to. So I'm going to substitute. Instead of writing y on the first equation, I'm going to write 3x minus 8. That's the substitution right there. 3x minus 8 instead of y is equal to the rest of the equation, negative 2x plus 2. And now we see we have one equation, one unknown variable. We can use our basic equation solving skills to complete this process to find x. I would add 2x to both sides, get all my x's together, looking at 5x minus 8 equals, now 2x minus 2x, that's gone. That's eliminated, that's what we wanted, 2. Let's get the x by itself. Start by getting rid of the constant. Add 8 to both sides. 5x equals 10. Last but not least, 5 times x. The opposite of multiply is divide. Both sides by 5 in this case. X is 2. So the x value that makes both of these equations work is 2. However, I need to find a y value. So I got to take this 2 and substitute into either of my two equations. It doesn't matter. Remember, the solution makes both equations true. So this works on both of them. Pick one. Let's go ahead and use the bottom one, 3x minus 8. So we go back to the first equation. Y equals 3 times x, which we now know to be 2. Minus 8. And just evaluate that. 3 times 2 is 6. 6 minus 8 is negative 2. So we now have both x and y values that work on both equations. The coordinate would be 2, negative 2. Meaning if I were to solve this by graphing, my two lines would cross at that point.